Welcome everyone. I am Prakash, Assistant Professor, Department of ECE, KIT, Kalinar Karnataka Institute of Technology. Today I am going to discuss about OSI model and its layer architecture and to show the interface between the layers and briefly discuss the function of each layers in the OSI model. Introduction. OSI model established in 1947, the International Standard Organization is a multinational body dedicated to worldwide agreement on international standards. It created a model called the Open System Interconnection, which allows different systems to communicate. Open system is a set of protocols that allows any two different systems to communicate regardless of their underlying architecture. Layers in the OSI model. Topics discussed in this session: first, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. The 7 layers can split into 3 subgroups. Layer 1, 2 and 3, that is physical, data link and network or network support layers. They deal with the physical aspects of moving data from one device to another. Layer 5, 6 and 7, that is session, presentation and application or the user support layer. They allow interoperability among unrelated software systems. Layer 4, that is transport layer, ensures end-to-end reliable data transmission, while data to ensure reliable transmission on a single link. Physical layer. Physical layer is responsible for movements of individual bits from one hop node to the next. Physical layer coordinates the functions required to transmit a bit stream over a physical medium. It deals with the mechanical and electrical specifications of interface and transmission medium. The layer is concerned with, first one, physical characteristics of interfaces and transmission medium. It defines the characteristics of the interface between the devices and transmission medium. Bit representation. The physical layer defines the type of encoding depends on transmission medium. Before transmitting the bits, it must be encoded into signals, maybe electrical or optical data rate. Physical layer defines the transmission rate, that is number of bits sent each second. Bit synchronization. The sender and receiver must use the same bit rate and their bit level must be synchronized. Line configuration. The physical layer concerned with the connection of devices to the medium. It may be point-to-point or multi-point configuration. Physical topology. Physical layer defines how devices are connected to make a network, for example, mesh, star, ring, bus or tree topologies. Mode of transmission. This layer defines the direction of transmission between two devices, example, simplex, off duplex or full duplex. The physical layer as shown. From data link layer, the informations are converted into zeros and ones. The zeros and ones are converted into electrical signals through line coding techniques. Second, data link layer. Data link layer is responsible for moving frames from one hop node to the next. It's also responsible for transmitting a group of bits called frames or packets to the adjacent node without error, node to node delivery. Network layer passes a data unit to the data link layer. At this stage, the data link layer adds header and tailor information to it. This now becomes a data unit to be passed to the physical layer. The header and tailor contains the source and destination address and other control information. Data link layer is responsible for framing. First, the data link layer divides the stream of bits received from the network layer into manageable data units called frames. Second, physical addressing. The header and tailor are added containing the physical address of the adjacent node that connects the network to the next one. Flow control. This avoids overwriting on the receiver's buffer by regulating the amount of data that can be sent. Error control. This layer adds reliability to the physical layer by adding the mechanism, that is CRC, cyclic redundancy check, go back and sliding window protocol, to detect and retransmit damaged or lost frames. Error control is normally achieved through the tailor added to the end of the frame. Access control. When two or more devices are connected to the same link, this layer protocol are necessary to determine which device has control over a link at any given time. Data link layer figure as shown. This is one example of data link layer. In bus topology, there will be 5 systems or connector. Data link layer format will be of first left side tailor end, and next will be of information, that is data, and next will be of contain address of source and destination. The tailor T2 as represented, and source address will be of 10 and destination address 87. The informations will be communicated from source address to destination address, that is 10 to 87. Network layer. Network layer is responsible for the delivery of individual packets from the source host to the destination host. This layer ensures the successful delivery of a packet to the destination node. To perform this, it has to choose a route. This layer is responsible for logical addressing. This logical addressing adds a header to the packet coming from the upper layer that include the source and destination address, that is logical address of the sender and receiver. Second one, routing. When independent networks or links are connected together to create an inter-network or a large network, the connecting devices called router or gateway route the packets to their final destination. Transport layer. Transport layer is responsible for the delivery of message from one process to another, that is source to destination, that we can call as end-to-end delivery of the entire message. Whereas the network layer is responsible for end-to-end delivery of individual packets. Transport layer is responsible for port addressing. Source to destination delivery means delivery not only from one computer to other, it is from a specific process, that we can say as application program, on one computer to a specific process, that is application program on the other. For this purpose, transport layer header includes type of address called a service point address or port address. Second will be on segmentation and reassembly. The transport layer breaks a message into transmittable segments, that we can say as a packet, numbers them by adding sequence numbers at the source, and uses the sequence numbers at the destination to reassemble the original message. Third one, connection control. This layer can be either connectionless or connection oriented. For connectionless services, each segment treats independently and delivery to the transport layer at the destination host. In connection oriented services, the connection should be established first between the transport layer of the sending and the receiving host. After the packets are delivered, this connection will be terminated. Flow control. This layer takes care of the process to process flow control. Error control. Similarly, the error control is also performed here from process to process, as shown in the figure. Next one, session layer. Session layer. is responsible for dialogue control and synchronization. The responsibilities of session layer includes the following. First one, dialogue control. The session layer decides which user and application sends data at what point of time and whether the communication is simplex, off-duplex or full duplex, synchronization or checkpoint. The session layer divides a stream of data into subdatas for avoiding retransmission of entire message by adding checkpoint or synchronization points. Presentation layer. When presentation layer is responsible for translation, compression and encryption, concerned with the syntax and semantics of information exchanged between two systems. Some of the responsibilities are translation. The translation between the sender and receiver message format is done by presentation layer if two formats are different. Example, ASCII code or EDCDIC code text file. Second one, encryption and description. The presentation layer performs data encryption and description for security. Encryption is the process of transmitting the original message to another form that is an unreadable. Description. Description is a process of reversing the encryption message to original form. Third one, compression. For efficient transmission, the presentation layer performs data compression before sending. It reduces the number of bits transmitted and decompression at the destination. The last layer, 7th layer, application layer. Application layer is responsible for providing services to the user. Some responsibilities of applications layer are network virtual terminal, that is remote login. A network virtual terminal is a software version of a physical terminal and allows a user to log onto a remote host. To do so, the application creates a software emulation of a terminal at a remote host. File transfer and access. This application allows a user to access, download or upload a file from to a remote host. Mail services. It allows the user to use the mail services and directory services. This provides distributed database source and access for global information about various objects and services. The summary of 7 layers. First one, different layers. Second column, data unit. Third one, layer. And fourth one, functions. I already said that physical data link network or network support layer, and fourth layer, transport layer, is nothing but an end-to-end connections and reliability. Its data unit is segment. And last 3 layers, that is session, presentation, applications or user support layer. Thank you.